Good morning, viewers. Welcome to Jonas Research. Today, we are going to learn about decision tree. So, one may ask, what is decision tree? So, basically, decision tree is a machine learning algorithm that is used for classification and regression tasks. We use that one to a kind of splitting data or in order to know which kind of um, method should we go, which kind of method or approach should we use. So decision tree basically splits the data for us so that it will help us in making our decision in firms and any other business where you find yourself. Example, in education, it helps us to predict students' performance. You get me? If we know this kind of subject, if we take this kind of subject out, how it really affects the students, or if we add this kind of subject, how it really affects the students. In agriculture too, we can use for something like disease. Yeah, disease, crop disease classification. We want to know the disease affecting the crops, which kind of factors that really affect the crops very well. So basically that's what decision tree is. So it's really graph it so that we know how we can make our decision. Do you get me? So in order to start our decision tree in R, normally we do it manually in our tertiary institution when you are doing mathematics, statistics, actuarial science, or wherever you find yourself. In decision tree, we do it manually. You draw your graph manually and those kind of stuff. So today we are going to learn how we can put that kind of thing to practice in R. So first, before you start, you have to first install your packages. You have to first install your package. So we are going to use first as well. We are going to use our Carrot. So you have to first import it. Carrot is it contains the packages of machine learning algorithm. You get me? So you are supposed to install it first. So if you don't have it, you install it. I already have it, so I'll not install it. If you install it, it will take a time. So can you take your time for it to install? And you also install our paths.plot. That's what we are going to use to plot our decision tree. So after installing it, you will library it. Going to library it. Okay. So we are going to use this data. That's train dot. It's a train data containing series of variables. So after importing it, we will view it and we see how it look like. So this is how the Titanic train data look like. So it's talking about passengers, those who survive, the P class, that's the whether first class. In train we have different chambers. It's like a ticket, how to book a ticket for a particular train, or a particular train, or even a plane, or a ship too as well. So the name of the person, the sex, the age, the chamber, the blah blah, those kind of stuff. That's where we use in train, the ticket number, the fare, and the chamber, and what you're embarked on. So previously, I always tell you, you're supposed to know the meaning of each variable when you get a data from a firm to analyze. You're supposed to know the meaning of each variable. You get me? Yeah. So I'll just go straight. I will teach you how we can plot decision tree to make decision as well. So this one, you can see the order of the that's the class, letter first class. Okay, so I just want to change the order how it is. I just want to change it. So I'll put order, Titanic train P class. So I'm just converting the order as well. So I'll just convert it. Now we'll go straight to predict. So this time we just want to predict survivor. If in case there's an emergency, when you are trying to bring some technology, you're supposed to know the emergencies behind, the risks, the probability of risks behind if the things fail. So we are just going to know how, if there's an accident, the probability of those who are going to survive, those who are not going to survive, and those kind of stuffs. So if you are booking your train, you know which kind of chamber you are going to be. Do you get me? You know which kind of chamber you are going to be. Whether you're going to be in the first class, second class, or third class, or you are going to know whether the males or females are those who normally survive. You already know the story of Titanic. When it's crashed, they were sending the females first. In the lifeboats, they were sending the female first before the male. So basically, you already know logically, female are those who are going to, be the most to survive. Do you get me? So now we are going to start with sex. We are going to know whether males or female, if there's any accident, and if there's a rescue team, which one of them is going to survive, have the higher survival rate. Do you get me? So I'll just library the R part. They are just used for plotting. Do you get me? Yeah, they are just used for plotting. So I'll library them. And the options is because my plots, I've enlarged my this one, so the plot side will be very small. So I just want to use the options so that the dimensions of my plots. So basically, these are just the dimensions of my plot. So that's why I've wrote options. Your plot weight is equals to 6. Your plot height is equals to 5. So that's my dimension plot. I just want to use that one to plot. So basically, you can change the dimension in order to suit what you want. So I'll just do that one. And now with the R part, we are going to, I said we are going to predict the survivor using the sex. So that's where we're using normal regression. This is a symbol for regression. So this is our dependent variable and this is our independent variable. So the sex is our independent variable and the survived is what? Our dependent variable. We are going to know how much the sex will affect those who will survive in the train. Do you get me? Yeah, so this is my variable name. I just wrote gender_tree, the R part, your dependent variable, your symbol, then the independent variable. And where the data is, that's the Titanic or train, the data we imported earlier on. So I'm going to run it. Yeah, so that's that. And now we are going to plot it. So in plotting a decision tree, we use PRP. That's the code for us to plot our decision tree. So first, you use your gender tree, the one that you did in order to predict for the survivor using sex, and the space, that's the interval I just want it to be, and how we should split, and the border and the column, So this one you can just change it in order to suit how you want your graph to be. You get me? So they are all just formatting options. So you can change it in order to suit how you want your graph to look like. So I'll run it and we see how the outcome is. So this is the outcome. I will enlarge it. So this is how it is. So the sex, that's the male. I think there was an error, you didn't write it. So there's supposed to be a year. So the male, and yes, and yes, what? No. You get me? Yes, and yes, no. So with the yes, you can see that for males, their survivor is what? 0.19. And for the females, their survivor is what? 0.74. So if there's any accident and there's a rescue team, where normally they consider the females more than the male. You can see it from the Titanic movie when it crashed, as I explained in there on the boats. When the boat came, they started with the females before now they went to the males. So as a male, you know that if there's any accident, females first, they say ladies first. So this data normally gives, it has already given us a particle of how, if there's an accident, in terms of sex, the females has higher rates of what survival than the males. So this is how your graph will look like. So that's the explanation. The males are what, their survival rate is what, 0.19, and the female is what, 0.74. So let's add the class to it. We are supposed to want to know whether, if you are in first class, second class, or third class in the train, and there's any accident and there's a rescue team, which one are they going for first? In your normal saying, you're supposed to know they will normally go for those in the first class, because we assume they are rich. So we try to rescue the rich people more than those who are poor. It runs everywhere. So let's see whether it is true in this our data. So basically that's what I did. So your survived, the survived, that's the dependent variable, and independent variable we have the sex plus the class. So we use the plus in order to add the sex and the class. So, and where we had our data from is the Titanic or train, as we imported earlier on. So we ran that one too as well. Then we plot it. Yeah. So let me zoom it. Let me see. Okay. So you can see that the males are here and the females are here. And with the males, those in third class and second class, yes, their probability is what, 0.14. So if you're a male and you are also not all that rich, and you decide to book the third or second class, you can see that your survival rate is what, 0.14. But if you're a male and at least you are in the first class, you have higher rates of what, surviving. Do you get me? And now let's go to the females too as well. If you're a female and you are in a third class, your survival rate is what, 0.5. Oh, okay, at least is better than you being a male and you being in a first class. So your survival rate is what, 0.5, and that's of you being a first and second class, your survival rate is what, 0.95. So those females who are also rich, and they have decided to book the first class or the second class train, their survival rate is what, 0.95. So this one is to help you if you want to book a train and you are thinking of any risk involved. So you are supposed to go for what, a first class or a second class as well. So that one is really going to help. And if you're a male and you're booking a train or any transport mean, you are supposed to go for what, a first class. Try and get money in order to book a first class. In case there's any risk, you have higher rate of surviving. So basically this is what Desicion Tree is talking about. How to make decisions when you have your data. So this one is for all of us. We are trying to learn. So if you are taking a transport, make sure you take the first class. Don't be stingy, go for the first class, and you have higher rates of what, survival. So this one, with the third prediction, we want to predict a survival using all the data available, all the columns, or all the variables available. So we use our parts, and we use our what, those who we are checking for those who survived. So our independent variable will be the sex, the P class, the age too as well. Normally they consider age too as well, whether you go for the children or you go for those who have grown, the aged people or the children, blah blah blah. So we will run this one as well, and we see the outcome. So you can see the outcome because the variable are too many. You can see the outcome. Yeah. So this one will just help you to make a better decision. You can see we consider the males, the females, using the age, blah blah blah. So this one is a very huge complex thing, and you can do it at your end, and you analyze it based on the explanation I've given earlier on. So basically this is what we call decision tree. So decision tree is really helping us to make decision based on the data that we have, whether we should go for option A or go for option B. Example is like you having a firm, and you want to expand the firm, or you want to build another firm. So you're supposed to know which one to go for, the risks involved, so that it will help you to take good decision, you get me, based on the profit that you want, so that you don't make any regrets later on in the future. So thank you for joining our class, and don't worry, the data will be shared in our link so that you can use to practice as well. So thank you, and God willing, next time, bye.